Thank you, Dr. Uehara, for the introduction. Our company, GEC Co. Limited, is located in Japan. Its president is Dr. Uehara, and he has researched thermal energy conversion since 1973. The two technologies that we are discussing today are discharged thermal energy and hot spring thermal energy conversion. These are used for electricity power generation and desalination. These technologies are perfect for coping with an increase in electricity demand as they use the local thermal energy resources. For example, process exhaust energies from industries can be used rather than having a cooling system. A DTEC system would generate electricity. This is done by using a simple generating system. Here for illustration is a Rankine cycle. The hot source is flown through an evaporator, while a cold source is flown through the condenser. Using these two temperature differences, a loop is formed to generate electricity. Very important point is the efficiency of the evaporator and condenser, and this is Dr. Uehara's specialty. He has promoted and developed plate-type heat exchangers, which reduce the quantity of working fluid, reduce the plant size, and reduce the cost. For example, the old tube heat-type heat exchangers can be, 6 of these are replaced by one plate-style heat exchanger in this example. The reason for this is a tube-type heat exchanger has a very small thermal efficiency zone and a very large ineffective zone, whereas in the plate cross-sectional area, the distance between the plates can be minimized, therefore decreasing the ineffective zone. This technology is thoroughly researched at the Saga University IO Center, and where desalination and power generation are also combined. Desalination is performed by flash evaporation under a vacuum area. No filters are used, and just the thermal difference is used. This is a diagram of the power distribution plant. On the left-hand side is the Uehara cycle patented by Dr. Uehara, power generation system, and on the right-hand side is the desalination system. Only temperature difference is used to operate these systems. STEC is used by the hot springs, so that energy is easy to understand. However, DTEC can be used by any industry that has waste heat. Potentials are oil refineries, steel works, concrete production are examples of these type of industries where large thermal exhausts are available. For example, here is a 4 megawatt DTEC system in an oil refinery in Japan. The oil refinery, instead of using a cooling system which requires energy, the DTEC system is installed to create extra electricity and fresh water, and it reduces the cost in the cooling cost. Here we have a table of OTEC, DTEC, and STEC versus other fossil fuel and nuclear power situations. The temperature ranges are lower, and the efficiencies are slightly lower. However, because they're natural resources existing availability, the overall cost is much cheaper. Therefore, the benefits of OTEC, DTEC, and STEC are electricity power and fresh water, cost reduction on the generation system, and also very environment friendly. Thank you very much. That's a DTEC and STEC presentation.